Hello there, and welcome to the Sleepy Science Channel. Tonight's journey takes us far into the vastness of the cosmos, to wander among stars, galaxies, and mysteries that stretch beyond imagination. This evening, we'll drift through the wonders of our universe. From the faint echoes of the Big Bang to the strange possibilities of distant worlds, we'll take it slowly, one gentle fact at a time. You may find yourself relaxing, or simply letting these cosmic curiosities carry you towards sleep. Some of what you'll hear will be calm and familiar, like the glow of starlight traveling for billions of years. Others will be astonishing, like black holes bending space itself, or planets drifting through the dark without a sun. But each wonder we explore will reveal a piece of the universe's quiet story, vast, beautiful, and always a little beyond our grasp. If you enjoy these calm explorations and would like to join us for more, consider liking and subscribing, or if you'd like, share your thoughts in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is rest. Let your breathing slow, let your thoughts soften, and let the quiet vastness of space surround you. Now, if you're ready, let's begin. The universe may be infinite, yet we see only a small part of it. When you look into the night sky, you're seeing only the smallest glimpse of what may exist. Our telescopes can peer across billions of light years, yet even then, the universe continues beyond our sight. It may stretch forever, endlessly unfolding, or it may curve back upon itself in ways we cannot yet imagine. What we can see is called the observable universe, a sphere around us limited by the age of light itself. Beyond that boundary, there may be countless galaxies, stars, and worlds, hidden not by distance alone, but by the very fabric of time. The thought is both humbling and soothing. We live inside a cosmic horizon, like a small island surrounded by an infinite sea. To gaze upward is to stand at the edge of everything we know, with the possibility that the universe has no edge at all. A mysterious force called dark energy is pushing space apart. Not only is the universe expanding, it is expanding faster and faster, as though pushed outward by a hidden force. Astronomers call it dark energy, a mysterious pressure woven into the fabric of space itself. We do not know what it is, only that it makes up most of the universe, and its effects grow stronger with time. Because of dark energy, distant galaxies are racing away from us more quickly than ever before, and in the far future, they will drift beyond sight altogether. Dark energy is perhaps the greatest mystery in cosmology, a quiet force guiding the destiny of everything. It means that the universe is not static, but alive with motion, an ocean of space swelling ever outward. To rest beneath the stars is to feel its gentle pull, carrying all things slowly apart into the unknown. Black holes twist space and time into impossible shapes. At the heart of collapsed stars, or at the center of galaxies, lie black holes, regions where gravity grows so strong that nothing, not even light, can escape. To approach a black hole is to step into a place where space and time themselves are bent and twisted. Clocks tick more slowly. Light stretches and reddens. To an outside observer, anything falling in seems to freeze at the edge forever. Yet from within, the fall continues unstoppably to a hidden singularity. Some black holes are small, just a few times the mass of our sun, while others are monsters millions or billions of times larger. They are silent, invisible, and mysterious, yet they shape galaxies and stir the fabric of the cosmos. To imagine them is to confront the strange truth that the universe is not only vast, but stranger than our deepest dreams. Ancient starlight travels for billions of years before reaching us. Every time you look up at the stars, you are looking into the past. Light does not travel instantly. It takes time to cross the gulf of space. The light from our sun is 8 minutes old by the time it touches Earth. The light from the nearest stars may be decades old. And the faintest galaxies we see through telescopes send us messages that have been traveling for billions of years, crossing most of cosmic history to reach our eyes. In a way, the night sky is a vast time machine, showing us the universe as it once was. Some of the stars we see may no longer exist, their light still racing onward long after they have faded. To watch the stars is to catch whispers of ancient stories, written in photons, carrying memories across the ages. A faint cosmic glow still echoes from the birth of the universe. Long ago, the universe was a hot, glowing sea of particles. As it expanded and cooled, light finally broke free and began its long journey outward. That ancient light still exists, stretched into faint microwaves by billions of years of cosmic expansion. We call it the cosmic microwave background, a dim glow that fills the entire sky, invisible to our eyes, but detectable with sensitive instruments. It is the afterglow of the Big Bang, a relic from when the universe was just a few 100,000 years old. To map it is to see the first ripples of structure, the seeds of galaxies and stars that would one day form. Quiet, ancient, and everywhere, this glow is the universe's oldest light, a whisper from its fiery beginning, still surrounding us as we drift through space. An invisible web of dark matter holds the galaxies together. Though galaxies are made of stars, gas, and dust, these visible pieces are not enough to explain how they move. Something unseen must be at work, holding them in place. That something is called dark matter, an invisible form of matter that does not shine, does not glow, and cannot be touched, but outweighs all the stars we see. Dark matter forms a vast hidden web, its gravity sculpting the large-scale structure of the cosmos. Galaxies are like beads caught along its threads, bound together by its invisible hand. Though we cannot see it, we can measure its presence in the motions of stars and the bending of light. To imagine the universe without dark matter is impossible. It is the silent framework upon which all else hangs. We live inside its shadowy embrace, held by something we cannot yet fully know. Galaxies drift like islands across an endless sea of darkness. Each galaxy is a floating city of stars, bound together by gravity, yet adrift in the vastness of space. They glide slowly, silently, across a cosmic ocean, their spirals and ellipses shaped by billions of years of motion. Our own Milky Way is just one of trillions, moving gently through the void, drawn by the subtle pull of its neighbors. Sometimes galaxies approach one another, merging in long, graceful dances that take hundreds of millions of years. Other times, they drift apart, carried on the steady current of cosmic expansion. When we look at a galaxy far away, we see it not as it is now, but as it was millions or billions of years ago, frozen in the past. To imagine them all, scattered like glowing islands across a dark and endless sea, is to glimpse the quiet majesty of the universe. Stars are forged in hidden nurseries of gas and dust. In the quiet depths of space, there are vast clouds of gas and dust, dark, cold, and invisible to the naked eye. Yet within these clouds, stars are born. Gravity gathers the gas together, pulling it inward until pressure and heat ignite a new light. These stellar nurseries are veiled places, glowing softly in infrared, where hundreds or even thousands of stars may form at once. The Orion Nebula is one such nursery, visible from Earth as a hazy patch of light, yet inside it lies an entire cradle of suns. Every star we see in the sky was once born in such a hidden place, emerging from darkness to shine for millions or billions of years. To know this is to realize that the universe is always growing, always creating. Even now, as we drift to sleep, new stars are kindling their first light. Some stars burn with a gentle glow for billions of years. Not all stars live fast or die young. Some, like our Sun, shine with a steady and patient glow, burning hydrogen slowly in their cores. These stars can endure for billions upon billions of years, giving warmth and light to the worlds that circle them. Their lives are measured not in centuries or millennia, but in ages so vast we can barely imagine them. They rise, shine, and continue, while civilizations bloom and fade on planets that may orbit quietly nearby. When you look up at the night sky, many of the stars you see are these long-lived companions of the cosmos, content to glow softly for eons. They are steady candles in a universe of change, constant enough to guide life, and enduring enough to remind us that time, even on the grandest scale, can be gentle and unhurried. Others end in explosions bright enough to outshine a galaxy. Some stars live fiercely and end suddenly, in an explosion called a supernova. When their fuel runs out, their cores collapse under immense gravity, and in an instant, the star releases a wave of energy so powerful it can outshine an entire galaxy for weeks. These cosmic fireworks scatter heavy elements across space: iron, gold, calcium, carbon, the very ingredients of planets, oceans, and life itself. Without supernova, Earth could never have formed. To witness one is rare and astonishing. Astronomers on Earth have recorded them throughout history, sometimes appearing as sudden new stars bright enough to be seen in daylight. Yet they are not endings alone. Each explosion is also a beginning, enriching the universe so that new stars, new planets, and perhaps new life can emerge. In the vast cycle of creation and destruction, even death brings light. Our Milky Way contains hundreds of billions of stars. When you look up at the night sky, you see only a handful of stars. Yet our galaxy, the Milky Way, contains hundreds of billions. Most are too faint or too distant for our eyes to see unaided, but together they form a great spiral disk, stretching more than 100,000 light-years across. Within it are stars like the Sun, stars larger and brighter, and others barely glowing. Our galaxy is a vast starry city, its spiral arms threaded with gas clouds where new stars are born. To us on Earth, the Milky Way appears as a pale band across the sky, but in truth, that hazy glow is the combined light of countless suns. To realize that every point of light belongs to this enormous family is humbling. We live within a single galaxy, one among trillions, carrying the quiet glow of ancient starlight. At its heart lies a supermassive black hole. Deep in the center of the Milky Way lies Sagittarius A*, a supermassive black hole more than 4 million times the mass of our Sun. Invisible on its own, its presence is revealed by the way stars whirl around it, orbiting at incredible speeds, as though caught in the grip of an unseen giant. If you could stand near it, time itself would slow, light would bend, and space would stretch toward the abyss. Yet most of the time, it rests quietly, cloaked in darkness. Occasionally it flares, as gas drifts too close and vanishes into its depths. To know that such a monster resides at the heart of our home galaxy is both unsettling and awe-inspiring. And yet, it has been there since the Milky Way's earliest days, shaping its history and quietly keeping its place at the very center of our cosmic neighborhood. Galaxies can collide and merge into something new. Though galaxies look serene from afar, they are not still. Slowly, over billions of years, they drift together and collide. When they do, their stars rarely crash into one another. The spaces between them are too vast, but their gas and dust swirl, compressing into new bursts of star formation. Over time, two galaxies can merge into one larger system, reshaped and reborn. The Milky Way itself is on a slow collision course with our neighbor, the Andromeda Galaxy. In about 4 billion years, the two will begin to merge, creating a single new galaxy that astronomers sometimes call Milk Dramida. From Earth, if life still watches, the night sky will blaze with streams of stars as the two galaxies intertwine. What seems calm now is part of an endless, graceful dance where galaxies meet, merge, and emerge transformed, more luminous than before. Stars often form in clusters, like families born together. When stars are born in dense clouds of gas and dust, they rarely emerge alone. Instead, they form in clusters, hundreds or thousands at a time, like families born from the same cradle. These clusters can be tight and brilliant, shining as jewels in the sky, or loose and scattered, slowly drifting apart over time. Our Sun, too, was likely born in a cluster billions of years ago, surrounded by sibling stars that have since wandered away across the galaxy. Some of those long-lost siblings may still exist, hidden among the Milky Way's billions. To think that every star has a birth family is strangely comforting. The stars we see at night are not just scattered randomly, but are the children of vast, ancient nurseries. They remind us that even in the cosmos, creation happens in gatherings, where many lives begin together. Some stars travel alone across the galaxy. While many stars are born in clusters, some become wanderers. These lonely stars drift through the galaxy with no companions, expelled from their birthplaces by gravitational encounters or collisions. They are sometimes called runaway stars, traveling at astonishing speeds, flung outward by the dynamics of their crowded homes. Others may simply form in isolation, quiet and solitary, far from bustling clusters. Imagine a star alone in the vast dark, carrying its light across thousands of light years, with no close neighbors, no nearby companions, just empty space stretching in every direction. Some of these solitary stars may even host planets, tiny worlds circling in quiet solitude. Though alone, they remind us of resilience, of endurance, and of the way light continues to shine even when surrounded by silence. The galaxy holds not only great families of stars, but also these solitary voyagers drifting endlessly. There are stars so large, they could swallow our solar system. Among the giants of the cosmos are hypergiant stars, swollen to unimaginable proportions. Some are so vast that if placed where our Sun is, they would stretch beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars within their blazing atmospheres. These colossal stars burn fiercely, living fast and short lives compared to smaller suns. Their outer layers expand outward like vast, shimmering veils of gas, trembling at the edge of collapse. From afar, they glow with an intensity that can outshine hundreds of thousands of ordinary stars. Yet their very size is also their undoing. They are unstable, prone to shedding their mass in great storms of gas, and destined to die in catastrophic explosions. To imagine such a star is to feel the scale of the universe, immense, fiery, and humbling, beyond anything we could ever witness up close. Others are barely bigger than a planet. But the opposite extreme. There exist stars so small They blur the line between planets and suns. These are red dwarfs, the most common type of star in the galaxy. Some are only a little larger than Jupiter, glowing dimly with cool red light. Though small, they are stable and can live for trillions of years, far longer than the universe has yet existed. Around many of these faint suns, planets circle quietly, perhaps warmed just enough for oceans and skies to form. To us, they are almost invisible without telescopes, hidden by their faintness, but they make up the majority of stars in the Milky Way. If life is abundant in the universe, it may be these quiet, long-lived stars that host the greatest number of worlds. They remind us that greatness in the cosmos is not always about size or brilliance, but endurance. Pulsars spin with the precision of cosmic clocks. When massive stars explode, their cores may collapse into neutron stars, objects so dense that a teaspoon of their matter would outweigh mountains. Some of these neutron stars become pulsars, spinning rapidly and beaming radio waves from their magnetic poles. As they rotate, these beams sweep across space like the beam of a lighthouse. To observers on Earth, pulsars appear to pulse with astonishing regularity, ticking like cosmic clocks with a precision unmatched by almost anything in nature. Some spin many times each second, their rhythm steady for millions of years. Pulsars have helped astronomers test theories of gravity, map the galaxy, and even discover planets. Yet they are also haunting reminders of the power of collapse. The remnants of stars once blazing, now reduced to tiny, spinning embers, flashing endlessly in the dark, steady as time itself. Neutron stars pack the mass of suns into a city-sized sphere. Imagine compressing the mass of the sun into a ball no larger than a city. That is a neutron star, one of the densest objects in existence. Inside, matter is crushed into a strange state where protons and electrons fuse into neutrons, packed so tightly that the surface is harder than steel and gravity is nearly unimaginable. If you could drop a pebble onto its surface, it would strike with the force of a nuclear bomb. Yet despite their density, neutron stars are only about 20 kilometers across, tiny by cosmic standards. They are the remnants of massive stars that ended in supernova explosions, their cores left behind as these astonishing spheres. Some spin rapidly, others emit bursts of radiation, but all carry the legacy of stars long gone. They are monuments to extremes, small yet impossibly heavy, glowing softly in the vastness of space. Quasars shine brighter than entire galaxies. Far across the universe, astronomers have found beacons so bright they outshine entire galaxies. These are quasars, powered by supermassive black holes feeding on surrounding gas. As the gas falls inward, it heats to incredible temperatures, releasing light that can travel across billions of light years. Some quasars are so distant that we see them as they were when the universe was young, blazing like cosmic lighthouses in the early darkness. Though they are powered by destruction, they are also signs of creation, marking the growth of galaxies and the shaping of the universe itself. To see one is to peer into both power and mystery, the heart of darkness, blazing with light. They remind us that the cosmos is full of contrasts, the most radiant light born from the deepest gravity wells, and brilliance shining from the very edge of nothingness. There may be more planets than stars in the universe. For a long time, astronomers could only guess how many worlds might circle other suns. But now, with telescopes able to detect even the faintest dips of starlight, we know planets are everywhere. Almost every star seems to have at least one, and many host entire families of them. Some orbit close, some drift far, and some systems are unlike anything in our imagination. When you consider that there are hundreds of billions of stars in the Milky Way alone and trillions of galaxies across the cosmos, it becomes likely that planets outnumber stars themselves. Each one a world with its own history, its own landscapes, its own silent orbit. The night sky above you, filled with stars, is in truth filled with more unseen planets than shining suns, countless hidden places circling quietly in the dark. Some worlds are covered entirely in oceans. Imagine a planet where there is no land at all, only endless ocean stretching in every direction. Astronomers call them ocean worlds, and they may be common in our galaxy. These planets are covered in deep layers of water, perhaps hundreds of kilometers thick, with currents, storms, and waves rolling across their entire surfaces. Beneath, there may be high-pressure ices or even hidden oceans warmed by internal heat. If life were to evolve there, it would live in seas without shorelines, drifting forever in alien tides. Even in our solar system, moons like Europa and Enceladus hint at vast hidden oceans beneath their icy shells. To think of a planet entirely given to water is to imagine something both familiar and strange. A world like Earth, yet without continents, only an eternal sea under foreign stars. Others burn with seas of lava. At the other extreme, a world so close to their stars that their surfaces are oceans of fire. Temperatures soar high enough to melt rock, creating vast seas of lava that churn and glow like rivers of molten metal. Some of these planets are called lava worlds, where dayside heat is unbearable, while the night side may freeze into stillness. The contrast can be extreme, one half blazing, the other silent and cold. These planets remind us how violent and varied the cosmos can be. To imagine standing on one is impossible. The ground itself would ripple with heat, and the sky would shimmer with burning light. Yet they exist, circling in tight, dangerous orbits, showing us what happens when gravity pulls a world too close to its star. They are fiery reminders of how delicate balance must be for life to thrive. Some planets rain diamonds in their skies. Far from Earth, in the crashing atmospheres of giant planets like Neptune or Uranus, carbon may fall as rain. But instead of water, the pressure and heat transform it into diamonds. These glittering crystals form deep in the atmosphere, tumbling downward like gems from a hidden storm. On some worlds, scientists think the entire mantle could be made of diamond, forged by unimaginable pressures. Even exoplanets far away may experience the same. It's a vision both surreal and beautiful. Rain that sparkles, not with drops of water, but with shimmering jewels. The universe, in its variety, creates weather beyond anything Earth has ever known. To drift to sleep imagining a storm of diamonds falling endlessly through alien skies is to realize just how strange and how wondrous other worlds might truly be. There are frozen worlds of ice and ammonia. Not all planets burn with fire. Many drift in the cold outskirts of their systems, wrapped in layers of ice. These frozen worlds may be covered with ammonia snow, methane glaciers, or icy plains stretching endlessly under dim starlight. Some may be solid spheres of frozen gas, while others conceal oceans beneath their frozen crusts. In the distant reaches of our own solar system, objects like Pluto and Triton remind us of this strange category of worlds, cold, silent, and often tinted with colors from frozen chemicals. Though lifeless on the surface, they may still hold secrets beneath. To stand on one would be to see a sky with little light and a horizon of endless frost. They are reminders that not all planets glow with warmth. Some are places of silence, where time itself seems frozen, waiting in the dark. Rogue planets drift through space without a star. Most planets orbit suns, but not all. Some are set adrift, torn away from their systems, or perhaps never bound to a star at all. These are rogue planets, worlds wandering the galaxy in eternal night. Without a sun to warm them, they may still glow faintly with heat left over from their birth, or be warmed by radioactive elements within. Imagine a world with no sunrise, no sunset, only darkness, with moons or rings circling in silence. Some might even host subsurface oceans, hidden beneath thick crusts of ice, warmed only by the planet's core. To float endlessly, carrying oceans, mountains, or storms into the deep dark between stars. That is the fate of a rogue planet. They are cosmic orphans, solitary travelers through the endless night. Some planets orbit two suns at once. In some systems, two stars circle each other like partners in a slow dance. Around them, planets conform, locked into orbits that bring two sunrises and two sunsets each day. These are circumbinary planets, places where the sky glows with two suns. Sometimes the stars are close together, appearing as twin lights in the heavens. Other times they drift farther apart, creating shifting patterns of warmth and shadow. The landscapes on such a world would change in rhythms we can only imagine, with skies lit by double dawns and long, complex twilights. Though once thought unlikely, astronomers have found real planets in such orbits, proving that the universe is more inventive than we guessed. To imagine standing on one is to feel like a character in a dream, a world warmed by not one, but two guiding stars. Others circle so close they are torn apart. Some planets orbit so close to their stars that they are locked in a perilous embrace. Gravity stretches them, pulling their shapes into ovals, while intense heat strips their atmospheres away. In the most extreme cases, these worlds are literally torn apart, their matter pulled off and devoured by the star itself. These planets are often called hot Jupiters or ultra-close exoplanets, circling in just days or even hours. The forces they endure are unimaginable, shaping them into strange forms and leaving behind trails of gas streaming across space. They remind us that not all orbits are safe or stable. Some worlds live on the edge of destruction, held too close to the very stars that once gave them life. To picture them is to feel the power of gravity itself, shaping destinies with no escape. Some are so distant they take millennia to complete an orbit. While some planets skim close to their stars, others wander far on enormous paths. These distant worlds may take centuries, even millennia, to complete a single orbit. Their skies are dim, their warmth faint, and yet they remain bound by gravity, tracing their endless loops around the stars that hold them. In our own solar system, the dwarf planet Sedna takes more than 10,000 years to travel once around the Sun. Farther out, in other systems, there may be worlds even more remote, drifting in the thin light of their suns. Imagine a year that lasts longer than human civilization itself, a world where seasons unfold across entire ages. These planets move at the very edge of belonging, still tied to their stars, yet almost free. They remind us how vast space is and how many ways a planet can live. Moons may outnumber planets by the trillions. Planets may be rare jewels of the cosmos, but moons may be even more common. Around gas giants, around rocky worlds, even around dwarf planets, moons gather in abundance. Some are larger than planets themselves, with atmospheres and hidden oceans. Others are small, captured asteroids pulled into orbit long ago. In our solar system, moons outnumber planets by far, and if we look beyond, it is likely the same across the galaxy. Trillions of moons may circle their worlds, shaping tides, sparking volcanism, and sometimes even nurturing life. Europa, Enceladus, Titan. These moons in our own neighborhood already hint at the possibilities. Each is a world in miniature, unique in its landscapes and mysteries. To think of the universe filled with moons is to imagine a cosmos of endless companions, circling quietly in the glow of their parent worlds. Gravity can bend light like a lens. In the vastness of space, even light does not always travel in straight lines. Gravity, the same force that holds us to Earth, can bend the path of light as it passes near massive objects. This effect, predicted by Einstein, is called gravitational lensing. When light from a distant galaxy or star passes by something heavy, like a cluster of galaxies or a black hole, its path curves, as though it had passed through a giant cosmic lens. To us, the image may appear stretched, doubled, or magnified, revealing details we could not otherwise see. The universe, in this way, helps us look deeper into itself, bending and magnifying its own light. It is a quiet trick of nature, showing that space is not empty but flexible, and that gravity can shape even the most intangible thing, the light of the stars themselves. Distant galaxies appear multiple times in the sky because of it. Sometimes, when we gaze deep into the universe with our telescopes, we see something curious, the same galaxy appearing in several places at once. This strange vision is caused by gravitational lensing, where the gravity of a massive object bends light around itself like glass bending a reflection. To us, it can make one distant galaxy look like 2, 3, or even 4 separate images shimmering around the edge of the lensing mass. These cosmic mirages not only dazzle the imagination, but also allow astronomers to study galaxies too faint to otherwise detect, magnified by the bending of space itself. To think that we can see echoes of the same galaxy scattered across the sky is to realize how strange the fabric of reality truly is. The cosmos, through gravity, paints illusions that reveal deeper truths. Time passes differently in strong gravity. Time, which we often think of as steady and constant, can flow at different speeds depending on where you are. In regions of strong gravity, like near a massive planet, star, or black hole, time slows down compared to places with weaker gravity. This is not just theory. It has been measured with delicate instruments, even between clocks on mountaintops and clocks at sea level. In space, near the densest objects, the effect becomes extreme. To an outside observer, everything near a black hole seems to slow, as though caught in a never-ending pause. Yet to the one experiencing it, time feels normal. This bending of time is part of the deep connection between gravity and the fabric of the universe. It reminds us that reality itself is flexible, and that time is not the same everywhere, but is woven into space like a living thread. A second near a black hole could be years far away. Imagine standing near the edge of a black hole. To you, each second feels ordinary, passing as it always does. But if someone far away were watching, your seconds would stretch into years. This is the effect of gravitational time dilation taken to its extreme. The immense pull of the black hole slows time so dramatically that an entire lifetime could pass for someone near it, while only moments slip by for those far from its reach. In science fiction, this idea often fuels stories of travelers returning home to find centuries gone. Yet it is no mere story. The math of relativity shows it to be real. To think that time itself can stretch and warp depending on where you are is humbling. Near a black hole, the border between minutes and millennia blurs, and reality itself bends into strangeness. Light from the early universe is stretched into gentle red. As the universe expands, the light traveling through it is stretched. What began as brilliant short wavelengths slowly lengthens, softening into redder hues. This effect, called redshift, is why the light from distant galaxies appears shifted toward red. The space between us and them has expanded during its journey. The farther away a galaxy is, the more its light is stretched, carrying with it a record of how the universe has grown. Some of the oldest light we see, from galaxies billions of light years away, has shifted so far that it now lies in the infrared, invisible to our eyes. With special telescopes, astronomers capture this softened glow, peering back into cosmic history. It is as if the universe itself sings in lower and lower tones as it ages, stretching its light into a gentle red, a quiet record of time's expansion. Some galaxies glow in ultraviolet beyond human eyes. Not all galaxies shine in colors we can see. Some glow most strongly in ultraviolet light, invisible to human eyes but detectable with special instruments. These galaxies are often bustling with newborn stars, which radiate in the hottest, brightest part of the spectrum. To us, they would look faint or ordinary, but through ultraviolet vision, they blaze with intensity, their spiral arms threaded with bright patches of star birth. It is like a secret version of the universe, hidden just beyond the limits of our senses. Telescopes such as the Hubble have revealed this unseen beauty, mapping galaxies in wavelengths our eyes cannot detect. They remind us that what we see is never the whole story. Beyond our narrow vision, the cosmos shines with colors and patterns invisible to us, yet woven deeply into the fabric of creation. Others shine in radio waves like celestial beacons. Some galaxies do not glow brightly in visible light, but instead shine fiercely in radio waves. These are often powered by supermassive black holes at their centers, driving jets that extend for thousands of light years. Through radio telescopes, they appear as enormous ghostly structures, far larger than the galaxies themselves. To human eyes, they may look dim, but in radio frequencies, they blaze like beacons. Radio galaxies allow astronomers to trace magnetic fields, energetic particles, and the activity of black holes across cosmic distances. They are reminders that the universe speaks in many voices, from visible light to invisible waves. By tuning into these hidden channels, we hear stories otherwise lost in silence. They are proof that the cosmos is not dark, but full of signals, calling out across the void in ways our eyes alone can never see. The universe is filled with invisible neutrinos streaming through us. Every second, trillions of particles called neutrinos pass through your body, through the Earth, and out the other side. They are nearly massless, ghostly travelers that interact so rarely with matter that they slip through planets and stars as though nothing is there. Neutrinos are created in nuclear reactions, in the heart of the Sun, in exploding stars, and even in the Big Bang itself. For decades, they were thought to be massless, but now we know they carry the faintest weight, enough to influence the universe's evolution. To detect them requires enormous underground detectors filled with pure water or heavy metals, waiting for the rarest of collisions. Yet whether we detect them or not, they are always here, streaming invisibly around us, through us, within us. The universe is not empty. It is alive with ghostly rivers of neutrinos. Cosmic rays from distant explosions strike Earth constantly. From the farthest reaches of the cosmos, high-energy particles race through space at nearly the speed of light. These are cosmic rays, born in supernovae, black hole jets, and other violent events. They travel for millions or billions of years before reaching Earth, where they strike our atmosphere in constant showers. Most are harmless, their energy absorbed before they reach the ground, but their presence is a reminder that the universe is always in motion, always sending whispers of distant violence across the void. Sometimes, The highest energy cosmic rays carry more punch than any particle we can create in human laboratories, a staggering force delivered by nature alone. Even as we rest beneath the calm night sky, we are bathed in these ancient travelers, cosmic messengers carrying the story of explosions that happened long before Earth was formed. Even empty space hums with quantum fluctuations. At first glance, a vacuum seems like nothing at all. But on the smallest scales, even empty space is restless. Quantum physics tells us that pairs of particles and antiparticles flicker in and out of existence constantly, borrowing energy for a moment before disappearing again. This jittery dance is called quantum fluctuation, and it happens everywhere, all the time. Though fleeting, these tiny events may have shaped the universe itself. The ripples in the early cosmos, which grew into galaxies and clusters, may have begun as quantum fluctuations stretched by cosmic inflation. What looks like nothing is, in truth, a froth of activity, subtle and unseen. To imagine this is to realize that emptiness is never truly empty. It is alive with potential, humming quietly beneath reality, a hidden foundation for all that exists. The universe began in a fiery expansion we call the Big Bang. More than 13 billion years ago, everything we know, space, time, matter, and energy, was compressed into a single, hot, dense state. In an instant, it began to expand. This moment, called the Big Bang, was not an explosion into space, but the stretching of space itself. From that first fiery expansion came all the seeds of the cosmos, the galaxies, the stars, the planets, and life itself. Though the idea can feel overwhelming, its traces are written in the sky, in the glow of the cosmic microwave background, and in the motions of galaxies still rushing apart. To know the universe began in such a moment is to feel both small and deeply connected. Every star you see tonight, every atom within you, began in that single cosmic unfolding, when time itself first began its endless journey. For a fraction of a second, space expanded faster than light. In the very first heartbeat after the Big Bang, the universe went through a phase called inflation. In less than a trillionth of a second, space itself expanded faster than the speed of light, swelling the cosmos unimaginably in an instant. This rapid growth smoothed out the universe, stretching tiny quantum fluctuations into vast ripples that would one day seed galaxies and stars. Though we cannot see inflation directly, its fingerprints remain in the structure of the cosmos all around us. To imagine it is almost impossible, a moment when distances greater than galaxies grew from something smaller than an atom. And yet, without it, the universe would be uneven, chaotic, and nothing like the graceful web we see today. Inflation was the silent breath that set the stage for everything that followed, the very first whisper of the cosmos as we know it. Matter and antimatter once battled for balance. In the young universe, energy condensed into particles of matter and their opposites, antimatter. Whenever the two met, they annihilated, leaving behind pure light. For reasons still mysterious, there was a slight imbalance. Just enough matter was left over after the battles to form the stars, galaxies, and planets we see today. Without that tiny excess, the universe would have been filled only with radiation, with no worlds, no atoms, no life. The symmetry of matter and antimatter was nearly perfect, yet it was the tiniest imperfection that allowed everything we know to exist. Scientists still search for answers to why the balance tipped. But to us, it is enough to know that the cosmos itself arose from this fragile difference, a faint bias toward matter that became mountains, oceans, and our own bodies. Existence is the echo of that ancient battle. The universe glowed like a brilliant fireball in its youth. Hundreds of thousands of years after the Big Bang, the universe was still a searing plasma of particles and light. It glowed everywhere, brilliant and uniform, like an immense fireball without edges. The photons within it scattered endlessly, bouncing from particle to particle, unable to travel far. To an observer then, there would be no stars, no galaxies, only an endless bright fog. Slowly, as the cosmos expanded and cooled, atoms began to form, and the fog lifted. Light could finally move freely, beginning its long journey outward. That ancient glow still exists as the cosmic microwave background, stretched into faint microwaves after billions of years. To remember that the universe was once a glowing sea is to see it not only as dark and starry, but also as something that once shone everywhere, a cosmic dawn before the first stars were ever born. Galaxies formed from tiny ripples in that early glow. The first structures in the universe began as the faintest ripples in the sea of early light. These tiny variations in density, born from quantum fluctuations, grew slowly over time as gravity pulled matter together. Where the glow was slightly denser, galaxies would eventually form. Where it was emptier, cosmic voids would stretch. In this way, the vast web of galaxies we see today traces back to the smallest of ripples, written into the afterglow of the Big Bang. Astronomers have mapped these patterns with satellites, finding the seeds of everything in delicate variations just a fraction of a degree warmer or cooler. It is humbling to think that the spiral arms of galaxies, the stars overhead, and even our own Milky Way all grew from those first subtle patterns. From whispers in the light, entire universes of form and beauty arose. The first stars were giants, short-lived and fierce. The earliest stars, born when the universe was still young, were unlike most we see today. They were immense, hundreds of times more massive than the sun, blazing hot and bright. These giants lived short lives, burning through their fuel in just a few million years before collapsing in powerful supernovae. With no heavy elements to temper them, they were made almost entirely of hydrogen and helium, pure children of the Big Bang. Their light pierced the darkness of the early universe, beginning the long process of reionization that made space transparent. Though none of these first stars survive today, their echoes remain in the elements they forged and the galaxies they helped shape. They were the first lanterns in a dark cosmos, brief but vital, laying the foundations for every star, planet, and world that would come after. They forged the first heavy elements in their cores. Within the blazing hearts of those early stars, nuclear fusion worked tirelessly. Hydrogen fused into helium, then into heavier and heavier elements as the stars aged. But only the most massive could go further, creating carbon, oxygen, and even iron before collapsing. When they exploded as supernova, these elements were scattered into space, mixing with the raw hydrogen and helium that still lingered. These heavy elements became the building blocks of later generations of stars, and eventually of planets and life. Without the furnaces of those ancient stars, the universe would contain no iron for blood, no carbon for cells, no oxygen for breath. To realize this is to see stars not only as lights in the sky, but as alchemists, forging the ingredients of life. We are the children of their fire, shaped by the remnants of their blazing cores. Every atom in your body was born in a star. The calcium in your bones, the oxygen in your breath, the carbon in every cell. All of it was forged in stars. Long before Earth existed, stars lived and died, scattering their elements into the galaxy. Over countless cycles, these elements gathered into new clouds, which collapsed to form new stars, new planets, and eventually, us. You are, quite literally, made of stardust. This is not a metaphor but a scientific truth. Without the alchemy of stars, there would be no matter to build life. When you look up at the night sky, you are looking at your own history, written in fire and fusion. Every twinkle is a reminder that we are deeply connected to the cosmos, our very bodies built from its remnants. To rest beneath the stars is to rest among family, kin to the universe itself. Without supernova, planets like Earth could not exist. The explosion of a supernova is both an ending and a beginning. In its final breath, a massive star scatters the elements it forged across light years, seeding space with carbon, silicon, oxygen, and iron. Without these gifts, there could be no rocky planets, no oceans, no living beings. Earth itself is built from the ashes of stars that lived and died long before. Our very planet is a mosaic of ancient starlight, reassembled into continents, mountains, and seas. Every rock, every tree, every heartbeat carries within it the legacy of explosions that tore stars apart. To know this is to understand that destruction in the cosmos is not only loss, but creation. Out of the death of stars comes the possibility of new worlds. Earth is proof, a planet formed from stardust, carrying life in the wake of stellar sacrifice. Even now, new stars continue to shape the universe. Though billions of years have passed since the first stars lit the cosmos, the universe is still creating. In vast clouds of gas, stars continue to form, igniting their fires and beginning their long journeys through time. Each newborn star shapes its surroundings, carving bubbles in the gas, sending out winds, and sometimes giving rise to new planets. The process is slow but unending, a quiet heartbeat of creation woven into the fabric of the universe. In places like the Orion Nebula, we can see this happening even now, nurseries where countless suns are being born. To realize that the universe is not finished, but still unfolding, is a comfort. Creation is not a single event in the past, but an ongoing story. As you drift to sleep, stars are kindling across the galaxy, adding their light to the eternal sky. Some black holes may be primordial, born in the early universe. Not all black holes may come from dying stars. Some scientists believe that moments after the Big Bang, when the universe was still dense and chaotic, regions of space could have collapsed directly into black holes. These are called primordial black holes, and if they exist, they could range from the size of mountains to objects as heavy as whole planets. Some may have evaporated long ago, while others could still drift unseen, hidden among the stars. They may even account for some of the mysterious dark matter that shapes galaxies. Though we have yet to find them, the idea is haunting, that scattered across the cosmos, there may be ancient black holes older than any star, relics from the very first heartbeat of time. Silent, invisible, and mysterious, they would be fossils of the universe itself, holding secrets from its earliest moments. Others can launch jets thousands of light years long. At the hearts of galaxies, supermassive black holes sometimes feed on gas and dust spiraling inward. But instead of swallowing it all, they can launch colossal jets of energy outward, stretching for thousands of light years. These jets, made of charged particles traveling near the speed of light, shine brightly in radio waves and can sculpt the very shape of their host galaxies. From Earth, we see them as ghostly streams, glowing across the darkness, marking the places where black holes feed. The power involved is beyond comprehension. The energy of entire stars funneled into narrow beams that pierce the cosmos. Yet in their violence, these jets also nurture creation, compressing gas and sparking new bursts of star formation. They are a reminder that black holes are not only destroyers, but also shapers, sculpting galaxies with both gravity and light. Entire galaxies can be stripped of their gas by neighbors. In crowded regions of the universe, galaxies do not always drift peacefully. As they move through clusters filled with hot plasma or pass close to larger companions, their reservoirs of gas can be stripped away. This process, called Ram pressure stripping, leaves galaxies barren, unable to form new stars. What remains is a silent collection of aging suns, slowly fading. Astronomers sometimes call these quenched galaxies, star cities cut off from the very fuel that once gave them light. To see them is to glimpse the quiet consequences of cosmic interaction, beauty turned stillness. Yet even in this stripping, there is motion and balance, as gas flows into other regions, feeding new creations elsewhere. Galaxies, like living things, are shaped by their environments, nurtured or diminished by the forces around them. The universe is never static. It is always reshaping itself, sometimes gently, sometimes with great force. There are stars that suddenly blink out and reappear. Most stars shine steadily, their light constant across years and centuries. But some behave strangely, fading away and then returning without warning. Astronomers have observed stars that dim so drastically they seem to vanish, only to brighten again later. Some may be hidden by passing clouds of dust, others by the strange dynamics of collapsing matter. A few may represent events we still cannot fully explain. One famous example, known as Tabby's star, baffled scientists with irregular dips in brightness that seemed too complex for planets alone to cause. These blinking stars remind us that even something as familiar as starlight can hold surprises. They are quiet enigmas, shimmering in and out of view like cosmic lanterns behind shifting veils. Each flicker is a question, a reminder that the universe still holds secrets, even in the lights we have watched for centuries. Some galaxies are so faint they are almost invisible. Not all galaxies glow brightly. Some are so diffuse their stars spread thin across vast regions that they are nearly invisible against the night sky. These ultra-diffuse galaxies can be as large as the Milky Way, yet contain only a fraction of its stars. To see them requires sensitive instruments, carefully tuned to pick out faint smudges of light from the darkness. Their existence challenges our understanding of how galaxies form and survive. Some seem to float quietly in space, while others live in crowded clusters, surviving despite their fragile appearance. They remind us that the universe is filled not only with brilliant spirals and dazzling ellipticals, but also with ghostly forms, barely there, delicate and strange. To know they exist is to imagine galaxies like wisps of smoke, drifting across the cosmos, almost unseen, yet still part of the grand tapestry of creation. Others are so dense they contain trillions of stars. At the opposite extreme, some galaxies are so crowded with stars that they contain trillions within their boundaries. These giant ellipticals are among the largest structures in the universe, glowing with the combined light of countless suns. They are often found at the centers of galaxy clusters, where they dominate their surroundings with their sheer mass. Their light is soft and diffuse, yet immense, like a glowing ball of starlight stretching across space. Within them, stars move in all directions, a chaotic sea without the graceful spirals we see in galaxies like our own. They are cosmic metropolises, star cities on a scale difficult to imagine. To gaze upon one is to see not just a galaxy, but a universe within a universe, packed with light and life, a radiant monument to the slow, patient growth of the cosmos over billions of years. Gamma-ray bursts can release more energy than the Sun will in its lifetime. Among the most powerful events in the universe are gamma-ray bursts, sudden flashes of high-energy radiation that can outshine entire galaxies for moments at a time. They are thought to occur when massive stars collapse into black holes or when neutron stars collide. In seconds, they release more energy than our Sun will in 10 billion years of steady burning. From Earth, they appear as brief bursts, lasting only seconds or minutes, but their brilliance travels across billions of light years. Though dangerous up close, they are far enough away that we only catch their echoes, brief whispers of unimaginable violence. They remind us that the universe, while often calm and quiet, also carries moments of staggering intensity. A single burst, unseen by our eyes but recorded by telescopes, tells of distant destruction, carrying the raw power of stars tearing themselves apart. Magnetars hold the strongest magnetic fields known. Neutron stars are already extreme, but a rare few are stranger still. These are magnetars, stars with magnetic fields trillions of times stronger than Earth's. Their fields are so intense they could strip information from a credit card from thousands of kilometers away. On their surfaces, crusts crack and shift, releasing bursts of X-rays and gamma rays. Though only a few dozen have been found, they are among the most powerful objects in existence. Tiny spheres just a few kilometers wide, yet holding more energy than entire planets. Magnetars are fleeting in cosmic terms, their intense fields fading after tens of thousands of years. Still, during their brief lives, they shape their surroundings in ways we can barely imagine. They are the universe's magnets, strange and fearsome, showing us that even among stars, there are extremes beyond comprehension. Gravitational waves ripple through space from colliding black holes. When black holes or neutron stars collide, they send ripples through the fabric of space itself. These are gravitational waves, first predicted by Einstein and confirmed only recently by detectors on Earth. Like ripples on a pond, they spread outward, carrying information about the cataclysm that created them. For a fraction of a second, the detectors stretch and squeeze by distances smaller than an atom, recording the faintest whispers of cosmic collisions. Each wave tells us about the masses involved, their spins and their fates. To think that space itself can ripple, and that we can feel those ripples across billions of light years, is astonishing. It is as though the universe has a voice, speaking in vibrations too subtle for us to hear, but strong enough to be measured. Through them, we listen to the deep music of the cosmos. Space itself can stretch and shrink with these ripples. Gravitational waves are not just disturbances moving through space, they are stretches and squeezes of space itself. As a wave passes, distances briefly change, expanding in one direction while contracting in another. Though the effect is incredibly small, it carries the story of some of the universe's most dramatic events. When two black holes spiral together, the waves they send out alter the very fabric of reality. On Earth, these ripples are so faint we would never notice them in daily life, but with sensitive detectors, we can measure the tiniest shifts in length. Each detection is like catching the echo of a collision across unimaginable distances. To imagine space itself stretching and shrinking is to realize that reality is more fluid than solid. The cosmos is not just a stage on which events unfold, it is part of the performance itself. Earth orbits a modest star in a spiral arm of the Milky Way. Our home planet circles a star that is neither the brightest nor the largest, but steady, calm, and long-lived. The Sun is a middle-aged, medium-sized star, resting quietly in one of the Milky Way's spiral arms, the Orion Arm, a minor branch compared to the galaxy's grander spirals. From here, We orbit at just the right distance for life to flourish, far from the crowded and dangerous galactic center, yet close enough to see the glow of our neighbors in the night sky. Our position gives us a peaceful vantage point, surrounded by open space, but not too isolated. To think of it is to realize how fortunate Earth is. A small world orbiting a modest star, tucked away in a quiet corner of a galaxy with hundreds of billions of suns. Humble, fragile, and yet just right for us to call home. Our galaxy is part of a small group called the Local Group. The Milky Way is vast, but it is not alone. It belongs to a collection of more than 50 galaxies, bound together by gravity, known as the Local Group. Our closest large neighbor is the Andromeda Galaxy, a spiral even bigger than ours, slowly moving toward us in a dance that will one day bring the two together. Scattered around are smaller galaxies, companions like the Magellanic Clouds, visible from the southern hemisphere, or tiny dwarf galaxies orbiting quietly nearby. Together, these galaxies form a kind of family, drifting through the larger cosmos as a unit. Though the Local Group is only a tiny fraction of the universe, it is our immediate neighborhood in the stars. To imagine it is to picture a cluster of glowing islands, floating together in the great ocean of space, companions on a shared journey through the dark. That group orbits within the vast Virgo supercluster. Beyond our Local Group lies something far larger, the Virgo supercluster, a sprawling collection of thousands of galaxies spread across hundreds of millions of light-years. Within it, galaxies are not randomly scattered but gathered into clusters, each bound by gravity into enormous cosmic cities. The Local Group is just one tiny suburb in this grand expanse, circling quietly at the edge. At the heart of the Virgo supercluster lies the Virgo cluster itself, a dense swarm of galaxies glowing like a cluster of jewels in the night. To us on Earth, these galaxies appear as faint smudges in the telescope, but in truth they are entire universes of stars. To know we belong to such a supercluster is to see how connected all things are. Our galaxy is not adrift alone, but part of an immense cosmic structure, a vast community of light. Even that supercluster is only one thread in the cosmic web. As immense as the Virgo supercluster is, it is still only part of something even greater. Across billions of light-years, galaxies and clusters gather into filaments, vast threads of matter forming a structure called the cosmic web. These filaments stretch and weave together, separated by enormous voids almost empty of galaxies. When mapped in 3 dimensions, the universe looks less like a scattered spray of stars and more like a living network, glowing strands crossing the dark. Our supercluster is only one thread in this cosmic tapestry, connected to others like fibers in a web, too large to comprehend. To imagine it is to think of the universe as not only vast, but beautifully organized on the grandest scale. We are part of a web that stretches across all space, a quiet reminder that nothing exists in isolation. Everything is connected. We see galaxies gathered into clusters like pearls on a string. Galaxies rarely exist completely alone. Gravity pulls them together into groups and clusters, bound into great families that can contain hundreds or even thousands of galaxies. When we look deep into space, we often see them strung along in long chains, aligned like pearls on an invisible string. These alignments trace the filaments of the cosmic web, showing the scaffolding of the universe itself. Each galaxy in a cluster carries its own billions of stars, yet together they move in harmony, orbiting their shared center of gravity. Sometimes clusters collide, merging into even larger collections. Other times, they quietly glide in place, glowing gently against the dark. To see galaxies gathered in this way is to glimpse the underlying patterns of creation. The universe arranges itself with an elegance we are only beginning to understand, building structures larger than imagination can hold. The cosmic web stretches across billions of light years. When astronomers map the positions of galaxies across the sky, a picture emerges. A vast web spanning the observable universe. The cosmic web stretches for billions of light years, its filaments filled with galaxies and clusters, while enormous voids lie in between. It is the largest structure we know of, a map of how matter has flowed since the dawn of time. Each filament is like a highway of galaxies, drawn together by the gravity of dark matter, glowing faintly in the darkness. From our tiny place inside it, we can only see pieces of this grand design, but computer simulations reveal its breathtaking scale. To imagine the cosmic web is to picture a universe alive with threads of light, woven across unfathomable distances. It is both delicate and immense, a structure so vast that even billions of years of light cannot capture it all. Most of the universe is empty, vast beyond imagination. For all its galaxies, stars, and planets, the universe is mostly empty space. Between galaxies stretch voids so large that a beam of light could travel for hundreds of millions of years without encountering a single star. Even within galaxies, the distances between stars are immense, with more emptiness than matter. Yet this emptiness is not nothing. It is the canvas upon which the cosmos is painted, the stage where the drama of stars and galaxies unfolds. To us, the universe feels crowded with stars, but in truth, they are scattered thinly across incomprehensible distances. This emptiness is what allows galaxies to drift, expand, and evolve, and without it, the universe could not exist as it does. To contemplate such vast silence is to feel both small and comforted. There is so much space, and yet here we are, a quiet spark within it. Yet everywhere we look, we find patterns of structure. Though the universe is mostly empty, it is not random. From the smallest scales to the largest, structure emerges. Stars gather into galaxies. Galaxies gather into clusters. Clusters stretch into filaments of the cosmic web. Even the ripples left in the glow of the Big Bang reveal patterns that seeded all later creation. This order arises naturally from gravity and motion, shaping the universe into a balanced whole. To us, it appears as beauty, spirals, clusters, threads, and voids, patterns repeated across vast scales. Everywhere we look, we find symmetry and rhythm, echoes of creation woven into the fabric of space. To realize this is to see the universe not as chaos, but as a living design, its structures both grand and delicate. We are part of that pattern, a tiny filament of life woven into the cosmos' endless weave. The universe has no center, it expands everywhere at once. It is tempting to imagine the universe as a balloon, expanding outward from a central point. But in reality, there is no center. The expansion happens everywhere at once, like the surface of the balloon itself stretching, with every point moving away from every other. To an observer in any galaxy, the universe would appear to expand around them, with distant galaxies rushing away in all directions. There is no single place where it all began, no edge from which it spreads. Instead, space itself grows, carrying galaxies with it. This can be hard to grasp, yet it is one of the most beautiful truths of cosmology. The universe has no special place, no preferred point. Everywhere is part of the expansion, equally central, equally vast. To live in such a universe is to belong not to a corner, but to everything. Every galaxy is racing away from us in the expansion. When astronomers measure the light from distant galaxies, they find it stretched, shifted toward red, a sign that the galaxies are moving away. The farther a galaxy is, the faster it recedes, carried outward by the expansion of space itself. To us, it seems as though everything is racing away, but to an observer in another galaxy, the same would be true. All galaxies see others rushing outward. This discovery, first made in the early 20th century, revealed that the universe is not static, but dynamic, alive with growth. It means that long after we are gone, the sky will slowly change, with distant galaxies fading beyond sight as expansion carries them away. To know this is to feel both the fleetingness and the grandeur of existence. The universe is always in motion, always growing, a river of galaxies flowing endlessly outward. Some stars are so cool they barely glow red. Not all stars blaze brightly in the sky. Some are so cool and faint that their light is barely visible. These stars, often called red dwarfs, glow with a deep crimson hue. Their heat so low they simmer rather than burn. Many are smaller than half the size of the sun, their light dim and steady, like embers that never quite go out. Though they may be faint, they are the most common stars in the galaxy, numbering in the hundreds of billions. Some live for trillions of years, far longer than the universe has existed so far. Around them, planets may circle quietly, warmed by the faintest glow. These tiny, cool suns are the quiet keepers of the cosmos, enduring when brighter stars fade away, a reminder that sometimes the smallest lights are the ones that last the longest. Others burn so hot, they shine blue-white. At the opposite extreme are the hottest stars of all, massive suns that shine in fierce shades of blue-white. Their temperatures can reach tens of thousands of degrees, blazing with energy so intense it bathes their surroundings in ultraviolet light. These stars are short-lived, burning through their fuel in only a few million years, but while they live, they dominate their regions of space. Their light sculpts nearby gas clouds into glowing nebulae, sparking new generations of stars. They are rare, outnumbered by smaller suns, yet their brilliance ensures they stand out in the night sky. To imagine one is to picture a furnace brighter than 1,000 suns, hot enough to melt anything we know, radiating with impossible intensity. Though fleeting, their beauty is unmatched, and their brief lives leave behind legacies of new stars, new elements, and new wonders. Brown dwarfs bridge the gap between planets and stars. There are objects in the universe that are neither fully stars nor fully planets. These are brown dwarfs, often called failed stars. They form like stars, collapsing from clouds of gas, but they never grow massive enough to ignite sustained nuclear fusion in their cores. Instead, they glow faintly with leftover heat, sometimes giving off only a dim red or infrared glow. Some are large enough to resemble small stars, while others are barely bigger than giant planets like Jupiter. They drift quietly through space, often invisible without special telescopes. Though they lack the brilliance of true stars, they are fascinating in their own right, a hidden population between categories, reminding us that the universe does not always follow simple boundaries. To imagine a brown dwarf is to picture a ghostly ember, glowing softly in the dark, neither star nor planet, but something in between. Some white dwarfs will crystallize into cosmic diamonds. When stars like our Sun reach the end of their lives, they shed their outer layers and leave behind dense cores called white dwarfs. These remnants, no larger than Earth, glow faintly as they slowly cool. Over billions of years, their matter may crystallize, forming enormous spheres of carbon and oxygen arranged like a diamond lattice. In time, they will become cosmic gems, stars transformed into giant diamonds drifting in the galaxy. Astronomers believe some white dwarfs we see today are already beginning this process, their cores hardening into crystalline form. To think of such a thing is breathtaking. Stars that once blazed brightly, ending not in fire, but in quiet transformation, leaving behind the largest diamonds the universe could ever create. Silent, eternal, and glittering invisibly in the dark, they are reminders of beauty, hidden even in stellar death. Others will one day fade into black embers. White dwarfs do not shine forever. After trillions of years, as they lose their heat, they will grow colder and dimmer, until at last they no longer glow at all. These hypothetical remnants are called black dwarfs, stars that have faded into darkness, embers cooled beyond visibility. None yet exist because the universe is not old enough. Even the oldest white dwarfs still shine faintly, their warmth slowly ebbing. But given enough time, the galaxy will one day be filled with these silent, darkened stars, relics of suns that once gave light and life. It is a haunting vision, a cosmos where the lights go out one by one, until only cold embers remain. Yet it also speaks to the deep patience of the universe. Even stars must rest eventually, fading gently into sleep after eons of shining. Hypergiant stars can shed entire shells of gas. Some of the most massive stars in the universe are unstable giants, their atmospheres so swollen and turbulent that they shed layers of gas into space. These hypergiants can lose as much mass in a year as our Sun will in its entire lifetime, throwing off shells of glowing material that expand outward like halos. Over thousands of years, these shells form intricate nebulae, glowing in the starlight as cosmic sculptures. The star itself continues burning fiercely, destined for a spectacular end as a supernova. Hypergiants live fast and end violently, but their eruptions help enrich the galaxy with elements that will form future stars and planets. To see one is to witness both beauty and fragility, a colossal star trembling on the edge of collapse, surrounding itself with veils of gas, leaving luminous reminders of its turbulent existence. Collapsing stars can form black holes in seconds. When the most massive stars run out of fuel, their cores collapse under the crushing force of gravity. In just seconds, the matter inside shrinks to an impossibly dense point, creating a black hole. The outer layers of the star explode outward in a supernova, scattering elements across space, while the core vanishes behind an event horizon. The speed and violence of this process is staggering, a star that shone for millions of years ending in a collapse that happens almost instantly. To imagine it is to picture an enormous sun folding in on itself, its light extinguished in a heartbeat, leaving behind a shadow in space. These events are rare to witness, but their consequences shape the galaxy, creating black holes that can grow, merge, and influence everything around them. Even in destruction, they are creators, opening doors to new mysteries. Some black holes consume entire stars whole. Every so often, a star wanders too close to a black hole. When it does, the black hole's gravity stretches and pulls it apart in a process called spaghettification. The star is shredded, its gas forming a glowing disk as it spirals inward, heating to millions of degrees before vanishing into the black hole. These violent meals can outshine galaxies for brief periods, as the infilling matter releases enormous energy. From afar, we see them as sudden flares of light, the signatures of stars being devoured. For the black hole, it is simply growth, feeding on what chance has brought too near. Though terrifying in scale, these events are also part of the balance of the cosmos, reminders that nothing is permanent, and that even stars can be undone by the gravity wells lurking silently in the dark. Others quietly sip gas from their surroundings. Not all black holes are dramatic in their feeding. Many grow slowly, drawing in thin streams of gas from their surroundings. As the gas swirls inward, it heats and glows faintly, but without the enormous flares of more violent meals. These black holes are quiet, hidden in the dark, revealed only by their subtle effects on nearby stars or by the faint X-rays of their glowing disks. In some galaxies, countless black holes sip gently on interstellar gas, growing steadily over billions of years. Though less spectacular than star-devouring events, this quiet feeding may be far more common. It paints a picture of the universe not only filled with sudden violence, but also with slow, patient processes unfolding invisibly. These silent black holes remind us that growth takes many forms, sometimes a sudden flare, and sometimes a slow sip across eternity. There may be black holes wandering the galaxy unseen. Most black holes remain hidden, without bright disks of gas or dramatic eruptions to reveal them. Some may drift alone through the galaxy, remnants of ancient stars, wandering invisibly through space. Astronomers believe there could be millions of these rogue black holes in the Milky Way, passing silently between the stars. We cannot see them directly, but we may detect them when their gravity bends starlight or nudges nearby stars in their paths. To imagine them is to picture shadows roaming the galaxy, unseen and silent, yet present. They are reminders that the universe holds far more than meets the eye. For every brilliant star we see in the sky, there may be countless invisible companions, traveling endlessly in the dark. These hidden wanderers remind us that space is filled not only with light, but also with mysteries that quietly drift beyond sight. The cosmos will continue expanding for billions of years. The universe is not still. It stretches, slowly, gently, carrying galaxies farther apart with every passing moment. This expansion began with the Big Bang and shows no sign of stopping. For billions of years to come, space will continue to grow and galaxies will continue to drift. The stars overhead may appear eternal, but the great web of galaxies is always in motion, always spreading wider. Though invisible to our senses, this expansion is constant, a background rhythm of the cosmos itself. To imagine it is to picture all of space breathing outward, forever stretching into the unknown. We live in a universe that is not fixed, but alive with change, its future already unfolding in the silent pull of dark energy. Even as we rest tonight, the cosmos grows larger, and the distances between galaxies stretch ever further into infinity. Distant galaxies will drift beyond our sight. As the universe expands, more and more galaxies will slip away. Beyond a certain distance, their light can no longer reach us, carried away faster than the speed of light by the stretching of space itself. In billions of years, the night sky will grow emptier, as only the closest galaxies remain visible. Eventually, future observers may see only the stars of the Milky Way and its merged descendants, unaware of the larger universe beyond. The cosmos will appear smaller, not because it has shrunk, but because its light has been carried away. We live in a fortunate time, when telescopes can still glimpse billions of galaxies across the sky. To imagine them fading from view is bittersweet, a reminder that the universe is not only vast, but changing, and that the vision we hold today is a fleeting gift of cosmic history. Stars will burn out, leaving darkness. Though stars feel eternal, each has a lifespan. In billions or trillions of years, they will exhaust their fuel and fade. The largest stars will collapse into black holes or neutron stars. Smaller ones, like red dwarfs, will simmer slowly before fading into faint white dwarfs. Over unimaginable stretches of time, the galaxy's stars will go out one by one, until only embers remain. The night sky, once alive with light, will darken into silence. Yet even in this fading, there is beauty. The elements forged in stars will remain, drifting in space, carrying the legacy of light long after it has dimmed. To think of it is to realize that nothing, not even starlight, lasts forever. But like a candle at the end of its flame, the stars will leave behind a memory of brilliance, a story of creation written into every atom. White dwarfs will slowly cool to nothing. When stars like the Sun end their lives, they leave behind white dwarfs, small, dense remnants glowing faintly with heat. For billions of years, these stars will shine softly, cooling slowly as their warmth fades. Eventually, after unimaginable spans of time, they will radiate no light at all. These invisible corpses are called black dwarfs, stars that have grown cold, silent, and dark. None exist yet, because the universe is still too young. But in the far future, when enough time has passed, the cosmos may be filled with them, quiet embers scattered through the void. They will be reminders of a time when stars once filled the skies, glowing across galaxies. To picture a universe of black dwarfs is to imagine silence, an end not in fire or violence, but in stillness, as light itself slips into memory. Black holes will evaporate over trillions of years. Even black holes, the darkest and most enduring objects we know, will not last forever. Through a process called Hawking radiation, they slowly lose energy, emitting faint particles as they shrink. Over trillions upon trillions of years, even the largest black holes will evaporate, vanishing in a final burst of light. This process is so slow that none have yet begun to fade. But in the far future, long after stars have gone dark, black holes will be the last luminous events in the cosmos. To imagine them evaporating is to picture the universe slowly emptying, its most powerful engines dissolving into nothing. What remains is silence, a cosmos without stars, without galaxies, only faint whispers of energy fading into the dark. It is a reminder that even the most enduring giants of space are not eternal, but subject to time itself. Even protons may one day decay. The matter that makes up our world feels permanent, as though atoms will last forever. Yet some theories suggest that even protons, the building blocks of atoms, may eventually decay. If so, then after unimaginable spans of time, every atom in the universe would slowly dissolve, leaving nothing but radiation behind. This would mean not only stars and galaxies would vanish, but matter itself would fade into energy. No mountains, no oceans, no planets. Only a thin mist of particles spread across endless space. Though this idea is not yet certain, it is a haunting vision of impermanence. Even the most solid stone may one day vanish, not in moments, but in ages so long they dwarf the history of the cosmos. To rest beneath the stars is to hold on to the fleeting gift of matter itself, fragile and temporary. The universe may end in a cold, quiet heat death. One possible fate of the cosmos is heat death, a time when all energy is evenly spread and no more work can be done. Stars will fade, black holes will vanish, and even particles may decay, leaving behind only a thin, uniform haze of radiation. In this vision, the universe does not end in fire or collapse, but in silence, an infinite stillness where nothing stirs. Time itself would continue, but with no change, no events, no warmth. It would be a cosmos asleep forever. Though it sounds bleak, it is also strangely peaceful, the ultimate quiet, the final drift into stillness. If this is the end, it will come not with violence, but with calm, after countless trillions of years. The universe, having burned bright for ages, will simply rest, its long story closing in infinite silence, or collapse back inwards in a big crunch. Another possibility is that the universe, instead of expanding forever, might one day slow, halt, and reverse. In this scenario, gravity overcomes expansion, pulling galaxies back together. The cosmos would shrink, growing hotter and denser, until all matter collapsed into a final singularity, a big crunch. If so, the universe would end as it began, in fire and density, time folding back upon itself. Some versions of this theory suggest it might not be the end at all, but part of a cycle, with each crunch followed by a new bang, a rebirth of creation. Though current evidence suggests expansion will continue, the idea remains powerful, a vision of the universe breathing in and out across eternity. To imagine it is to see not just an ending, but a renewal, a cosmos forever collapsing and blooming like a great cosmic heart. Some theories suggest it may bounce and begin again. In some models of cosmology, the universe does not end at all, but cycles endlessly between expansion and contraction. After reaching its largest size, it may collapse inward, only to rebound in another Big Bang, beginning again with new stars, new galaxies, and new stories. This is called the Big Bounce. Each cycle may erase the details of the last, yet carry forward some faint imprint, passing echoes of past universes into new ones. If true, the cosmos may have no beginning and no end, only an infinite rhythm pulsing across time like a heartbeat. To imagine such cycles is to see existence not as a straight line but as a circle, repeating forever, each turn different but connected. It is a comforting thought that even if our universe fades, another may rise, carrying the story forward into eternity. Others imagine new universes sprouting from ours. Another possibility is that our universe is only one among many. In this view, new universes may sprout from black holes or emerge from quantum fluctuations, each with its own laws of physics and its own unfolding story. Our universe may be just one bubble in a vast cosmic foam, with countless others floating unseen beyond. Some may last only moments. Others may grow vast and rich with galaxies. If this is true, then even as our universe evolves, others are being born in silence, each with its own beginning and end. To think of this is to expand imagination beyond even the stars above us. The cosmos may not only be infinite in space, but infinite in possibilities, with every universe a dream within a dream. We may live in just one of countless realities, each drifting quietly in the endless sea. Even black holes can get kicked across the galaxy. When two black holes merge, they do not always settle quietly. The collision can release powerful gravitational waves in one direction, giving the new black hole a kind of kick. This kick can send it hurtling through its galaxy at astonishing speeds, sometimes fast enough to escape entirely. Imagine a black hole, millions of times the mass of the Sun, drifting alone between galaxies, ejected by the force of its own creation. Astronomers have found evidence of these wandering giants, their influence revealed by the stars and gas they disturb in passing. To think of black holes, already so mysterious, being flung across the cosmos is both haunting and beautiful. They remind us that even the most massive objects are not fixed in place. The universe is full of motion, full of surprises, even in the shadows where light itself cannot escape. Some stars are stripped down to bare cores of pure carbon. Stars come in many forms, and some live such unusual lives that they end as something rare and strange. These are white dwarfs, made almost entirely of carbon, stripped of their outer layers until only their dense, crystalline cores remain. In essence, They are stars that have become giant cosmic diamonds, glowing faintly as they cool. Over billions of years, they will crystallize fully, their interiors hardening into lattices of pure carbon. Though they no longer shine as brightly as their former selves, they are treasures of the cosmos, brilliant in concept, if not in light. To imagine them scattered across the galaxy is to picture hidden jewels drifting silently among the stars. Each one is the remnant of a lifelong past, a shining ember turned into a gem, proof that even in death, stars can become beautiful in new ways. Most of the universe's history hasn't happened yet. Though the cosmos feels ancient, at more than 13 billion years old, this may only be its beginning. Stars, galaxies, and even black holes will continue to exist for trillions upon trillions of years to come. In fact, the era we live in, when stars are still shining, when galaxies are bright, may be just the opening chapter of an unimaginably long story. The majority of the universe's history lies ahead, in epochs we cannot truly fathom. There will be times of fading starlight, of cooling embers, of black holes slowly evaporating, and of silence stretching into infinity. To us, the present feels vast, but it is only a fleeting moment in the life of the cosmos. We live in a universe that is still young, its greatest ages yet to unfold, its longest dreams still waiting to be dreamed. Supernova remnants keep expanding for thousands of years. When a massive star explodes as a supernova, the brilliance fades within weeks or months. But the remains of the explosion, shells of gas and dust, continue expanding for thousands of years. These remnants grow into vast clouds, glowing faintly with the energy of the blast. One of the most famous is the Crab Nebula, born from a supernova observed on Earth nearly 1,000 years ago. It is still expanding, still spreading its filaments of light across space. These remnants are not only beautiful, they are the forges of new creation, scattering elements that will someday form stars, planets, and life. To see one is to glimpse the echo of violence, softened into delicate shapes of color and light. They are cosmic afterimages, reminders that even in endings, the universe leaves behind traces of wonder that linger for ages. The light from a distant star can be twisted by a single planet. We often think of planets as small compared to stars or galaxies, but their gravity still has power. When a planet passes in front of a distant star, it can bend and magnify the starlight through a process called microlensing. For a brief time, the star appears brighter, its light warped by the hidden planet's pull. This effect has allowed astronomers to discover planets far beyond our reach, worlds we could never see directly. To imagine it is to picture a tiny planet, invisible in the vast dark, briefly revealing itself by bending the light of a star billions of years old. It is proof that even the smallest bodies can leave marks on the grand stage of the cosmos. The universe is not only shaped by giants, but also by the quiet pull of unseen companions drifting silently in the dark. The universe once glowed with a brilliant orange light. Long before stars and galaxies filled the sky, the young universe itself glowed. As it cooled from its hot beginnings, the light it emitted shifted through colors. For a time, the entire cosmos was bathed in a brilliant orange glow, like an eternal sunset stretched across all of space. Slowly, as the universe expanded and cooled further, this light softened into red, then infrared, and finally into the faint microwaves we detect today as the cosmic background radiation. Though invisible to our eyes now, that orange glow was once everywhere, filling the skies of a universe without stars. To picture it is to imagine space itself alight, an infinite horizon glowing with warmth. The stars we see today are only echoes of that first radiance, the universe's original light show, fading into memory, but still whispering through the background of the cosmos. Some parts of the universe are cooling slower than others. The universe as a whole cools as it expands, but not all regions do so at the same pace. Some pockets of space remain warmer for longer due to differences in density, energy, or the influence of dark matter and dark energy. This uneven cooling leaves behind variations in the cosmic microwave background, tiny temperature differences that map the seeds of galaxies. Even today, astronomers find regions that appear slightly warmer or colder than expected, puzzling signs that the universe is not perfectly uniform. These subtle differences may hold clues to new physics, or even to processes beyond our visible horizon. To imagine it is to see the universe as a patchwork, not seamless but textured, with quiet variations woven into its fabric. Even in its vast calm, the cosmos carries hints of complexity, patterns still waiting to be fully understood. We might one day watch the birth of a new universe. Though our universe feels complete, some theories suggest that new universes may still form, sprouting from quantum fluctuations or budding off from black holes. If so, the birth of a new universe may one day be something we can glimpse, though never enter. It would appear as a bubble of space-time forming and expanding, disconnected from our own. To us, it might be only a flash, a brief distortion, gone before we could understand. But within that bubble, an entire cosmos could unfold, with its own stars, its own galaxies, and perhaps its own forms of life. The idea is dizzying, that new realities may be blooming even now, unseen beyond our reach. If true, then creation never truly ends. It is always beginning again. Universes growing out of universes, a cosmic garden with no final boundary, no final horizon. The cosmos is still ringing from its earliest moments. When the universe was born, it was filled with ripples of energy, vibrations in space-time itself. These primordial waves still echo faintly across the cosmos, etched into the background radiation, and perhaps still rippling invisibly through space. Astronomers call this the cosmic rinning, the aftershocks of creation, frozen into the fabric of reality. With sensitive instruments, we can trace these patterns, learning about the very first moments of the universe, when physics itself was still settling into form. To imagine it is to hear a faint, endless hum, the universe singing softly from its own beginning. Long after the first light faded, these echoes remain, telling a story billions of years old. They are reminders that the universe has memory, that every vibration, every ripple leaves a trace. Creation itself still resonates, quietly, in the silence of the night sky. The universe is vast, and you are a way for it to know itself. For all its galaxies, stars, and mysteries, the universe would be silent without eyes to see and minds to wonder. Through us, through life, thought, and curiosity, the cosmos reflects upon itself. Every question asked, every star admired, is the universe becoming aware of its own grandeur. You are made of its atoms, shaped by its stars, carried by its history. In you, the vast reaches of time and space have found a voice, a perspective, a fleeting spark of consciousness. To rest beneath the night sky is to realize that you and the stars are not separate, but parts of the same whole. The universe is vast beyond imagining, yet in you, it has found a way to wonder at its own existence. That is perhaps the greatest wonder of all. And so, we come to the end of our journey tonight. 100 wonders, each a tiny glimpse into the vastness of the cosmos. Stars blazing and fading, galaxies drifting, black holes whispering their secrets, and the quiet truth that even in silence, the universe is still alive with motion. As you listen, you may have felt moments of awe, or simply let the words wash over you like a tide, carrying you further into rest. Both are the right way to travel here. The universe does not hurry, and neither should we. Its story stretches across billions of years, and we are only passing through, one quiet night at a time. What lingers is not only the facts themselves, but the feeling they leave behind, that we are part of something vast, mysterious, and beautiful. Every atom in your body carries the history of stars. Every breath is connected to the cosmos that gave rise to you. In this way, you are never separate from the universe. You are always within it, and it is always within you. So, as you drift toward sleep, let your thoughts soften like starlight fading at dawn. Picture the galaxies slowly turning, their spirals endless and serene. Imagine stars being born in hidden nurseries and ancient light traveling across the dark to find you here. Let yourself rest in that vastness where time stretches and slows and the weight of the day grows lighter with every breath. If these explorations have brought you calm or sparked your curiosity in gentle ways, we'd love for you to like and subscribe and share your thoughts in the comments below. It helps others find their way here too, one sleepy soul at a time. And if you're still awake, you're welcome to join us in the next video, where another journey into wonder is waiting. But for now, there's nothing more you need to do. Just close your eyes, breathe slowly, and let the quiet beauty of the universe carry you into sleep. Good night.